So first, we're going to start with Dr. Honniball. She is a planetary geologist with NASA Goddard Space Flight Center, where she was also a postdoctoral researcher and is now an assistant research scientist with the University of Maryland College Park. She received her BS in astronomy from the University of Arizona, an MS in geology, and then geophysics and geology and geophysics, and then a PhD in Earth and Planetary Science from the University of Hawaii at Manoa. Dr. Honniball's research focuses on characterizing volatile compounds on the moon and other airless bodies by conducting lunar observations with Earth-based telescopes and developing instrumentation to measure surface hydroxyl in water under different environmental conditions. She is a co-I on NASA Viper and Psyche missions, and it's okay. You still were selected, which is fantastic. Let's see here. And was a science PI on SOFIA, for which she was awarded the Best SOFIA Thesis of 2020. She has served as a reviewer for the Journal of Geophysical Research Letters and is credited with numerous publications. Dr. Honniball is an inspirational mentor for the next generation of planetary scientists, frequently participating in school outreach activities. So with that, I welcome Casey to the stage.
So first, thank you so much for the wonderful introduction. I am just so humbled to be added to this list of long recipients of the Susan Mahan Niebur Award, many of whom I absolutely look up to as mentors in the science field, including Kelsey Young, Poverty Prem, Shuai Lee, Carrie, all of these people. So I'm just so honored to be receiving the same award. Now, when I was trying to decide what I was going to talk about, I thought about talking about volatiles. I thought about talking about remote sensing, but it just didn't feel right. So I reached out to Paul, Noah Petro, and Kelsey, and I was like, what do I even talk about? I've never had the chance to talk about anything that I want. And in some sense, they all told me to tell the story of how I got here. And so I decided that's what I'm going to do. But I'm going to do it in a little bit of a different way and share something really personal about how I got here. And I feel like it's appropriate because of the award that I'm receiving and who Susan was. Now, I never met her, but she was an advocate for early career scientists, women in science, and the minorities. And so you all think that there's something wrong with the title of my slide, but there's actually not. I did this on purpose. This is because this is how I used to write. When I was in first grade, I was diagnosed with dyslexia. And what is dyslexia? Well, it's a learning difference. And I've highlighted some of the symptoms that are associated with it. The ones that I struggle with the most are highlighted. So I struggled with reading. I struggled with sounding out words, and I still do. I avoid reading out loud, especially if I've never read the passage I'm about to read. I have poor spelling and grammar. I'm horrible at it. And I don't understand what's been read most of the time. So in the first grade, it was noticed that I was writing backwards. I was actually diagnosed with something called mirror dyslexia. So I would write completely backwards so you could hold it up to a mirror and read it. And this led to a very important decision for my parents, whether or not to have me repeat the first grade or move on to second grade. And I think this is probably one of the most important decisions they had made in my entire life. They had me repeat the first grade. One really interesting statistic about dyslexia is that 1 in 10 people have it, even if you don't know you have it. So I've been told that there's about 100 to 130 people in this room. So that means 10 of us, 10 to 13 of us have dyslexia. So my parents thought, you know, this girl, she can't read, she can't write, she loves performing arts. She's going to drop out at age 16 and join the circus. I mean, can you blame them? But I have to say, they made the best choice that they could make for me. They had me repeat the first grade, and they've supported me in every step of my journey. So I have to say thank you to them. All right, so I'm going to jump to fifth grade now. During first through fifth grade, I had an individualized education plan put in place, an IEP. This would allow me to have additional time on tests so that I had time to read and comprehend them. I was able to be tested in a separate environment from my peers. It could either be alone or in a smaller group. I was allowed to have the test read to me if I wanted it. And on top of the normal schooling that my peers were receiving, I was also being tutored. So not much happened between first and fifth grade. Once I got to fifth grade, I had an incredible tutor that helped me go from a reading level of the third grade to the fifth grade. He basically caught me up to my peers. I don't remember much of this time, but what my mom tells me is that he really connected with my disability because he had something similar. So he knew the tools to help me learn, to make a foundational educational difference in my learning abilities. I don't know what those are. To this day, I don't know what they are, but they're deeply ingrained in how I perceive anything that I need to learn or do in my daily activities. So now we're going to jump to high school. I had this IEP plan in place until I was a sophomore in high school. It ended up being that when I started high school, I didn't use the accommodations that were given to me. So when I was a sophomore, they decided to retest my eligibility for the IEP. They told me I wasn't dyslexic anymore. Now that's not possible. You cannot not be dyslexic if you are. It just turns out that I had learned how to cope. So in my day-to-day life, it no longer was a prominent factor in how I learned and how I presented the work I was doing. So I wasn't using the accommodations, and so they decided that I was no longer eligible for them. So I got no more additional time on tests, no more tutoring. And this was scary. I wasn't using them, but it was a crutch. And so I had to learn for myself that I was capable, that I was smart enough to continue and be successful. This was a really stressful time. Sophomore year to senior year, I was stressed all the time. I was working, I was doing I was doing cheerleading and going to school, and started really falling in love with physics. But my grades stayed the same. I ended up being an A+ student. And all throughout this, my parents continued to support and encourage me. So now, going to college, I struggled. High school did not prepare me for the difficulty of college courses. Now, I don't know if you know this, but in order to be successful in college, you need to have a reading rate of 250 to 350 words per minute to have additional time on tests to review your answers. My current reading rate is 130 words per minute. Not nearly enough. So I struggled in college, especially in the physics program. So I was actually at the University of Hawaii in the physics program, and I just couldn't do it. I was failing courses, and I was not enjoying it. My teachers were not helping me, and I didn't have the support that I needed for my test taking. So I ended up getting retested for dyslexia and was able to get the accommodations back. That was great, but it didn't change the fact that the physics program wasn't right for me. I originally went to college thinking I was going to do physics, going to get a bachelor's degree, go into the Institute for Astronomy and get a PhD, and become an astronomer. That was not at all what happened. It was not a linear path to here. So I ended up transferring schools. I went to the University of Arizona and transferred into an astronomy major, which is actually what I was really passionate about. And that made a big difference. I had additional time on tests again, which helped me be able to comprehend the questions and answer them properly, and then review them, which is important when you have a learning difference. And I have to say thank you to some of the people that were a part of my undergraduate career, because these people really started to show me and get me the experiences outside of the classroom, which was very instrumental to me being here today. So at the University of Hawaii, I joined the Instrument Development Lab under Dr. Gary Varner. And that the team is actually shown in the middle picture. And they taught me how to do fine pitch soldering through a microscope of computer electronics, how to test them, and how to start doing instrumentation and research. So they lit the pilot fire for my desire and passion for instrumentation. Once I transferred to the University of Arizona, I started working in the Steward Observatory Radio Astronomy Lab, not Sophia, and under Dr. Chris Walker. And under Chris Walker, we were studying the life cycle of molecular clouds using radio astronomy. And they actually were instrumental in defining my desire to be an observational astronomer and an instrumentation person. So with them, the top and bottom photos are some of the team members. The top one is of some of the team that went to the Apex telescope at La Chajantor, Chile. That's actually right next to the Very Large Array at 16,000 feet. We are inside the telescope installing the SuperCam instrument that would look at the Milky Way. And they would always send me into the tiny crooks and crannies to install hundreds of SMA cables because I was the smallest one. And I also got to do something pretty incredible. I got to deploy down to Antarctica twice on 2-month-long deployments to launch a high-altitude balloon telescope to study the Milky Way galaxy. And that's the team celebrating New Year's in Antarctica at McMurdo. All right, so here comes graduate school. I took the GRE and failed miserably. I didn't get test accommodations in time to take the GRE, so I ended up taking it in a setting very similar to this on those little desks that you have next to you with a strict timeline, a bunch of people around me, and honestly, that's not a conducive testing environment for anybody. So I applied with the GRE scores that I had because I didn't have enough time to retest with testing accommodations. And I got into one school, the University of Hawaii. I know it sounds crazy to go back to the school that you had just kind of failed out of, but I decided to give it a try because I wasn't going to the physics department. I was going to the geology and geophysics department under Rob Wright. Now, I have to say, I would not be here without Dr. Rob Wright. He did not look at my GRE test scores. He didn't care. He did not whatsoever care that I had issues taking tests. He wanted somebody that could be in the lab, work on the instrument, and actually make an instrument work. And so if it weren't for him not looking at those scores, I would not be standing here today. I'd probably be a pilot in the Air Force. So I think at grad school was finally when testing no longer dominated the success of my life, because it was no longer about the scores you would get. It was more so about the research you did, the products you produced, which is honestly what I thrive on. All right, so continuing grad school, many of you can recognize the face on this screen, and it's Paul Lucy, who was my mentor when I started working at the University of Hawaii with Rob Wright. We were working on an instrument, and he was my mentor, but he learned of my passion for astronomy and my undergraduate degree, and he said, "Hey, you want to observe the moon with the NASA Infrared Telescope facility?" And I was like, little hesitant. I was like, do I want to study the moon? Do I want to look for water on the moon? I was like, yeah, let's give this a try. So I'd say that we kind of hit the gold mine. Maybe I should say water mine, because we ended up looking at water with Sophia, and that has pretty much been why I'm here today, I believe. So as you can see, we had a great time observing on the IRTF, observing Sophia, and Paul ended up being the person that pushed my limits and helped me really figure out the passion of being a planetary astronomer with a side of instrumentation. So now I'm going to switch a little bit because we're kind of here today living with dyslexia and what it's like as a scientist. So what helps me? Well, using the proper fonts is really important. Calibri is a great font, but Times New Roman is terrible. It is just the worst font for a person with dyslexia to read. Recording lectures is really important because I am terrible at taking notes. Many people are, but it's really hard to listen and write and comprehend when you're trying to make sure you're writing down your notes properly so that you can read them again later. So usually what I'll do is I'll record a lecture, I'll listen during the lecture, I'll go back, write down my notes, and then I'll watch the lecture a third time, reading the notes that I had written so that I can start to comprehend the material. Audiobooks are great because they allow you to listen versus to read and write, which is usually where dyslexics have issues. Taking breaks and breaking things up is really important because if I try to read a page long of text, I don't comprehend anything. I have to read it 3, 4, sometimes even 5 more times. So if I break it up into smaller chunks, focus on that chunk, understand that chunk, and move on. Colored backgrounds are important too. I almost always have the night shift mode on my computer. It makes the screen yellow versus having a white and black background. And that is really important for me because I just cannot read and comprehend on a white and black, with black text on a white background. And then my wonderful colleagues, all of you here today that proofread and help me and inspire me and motivate me. So there's a ton of people to thank, but I'm going to call out a couple that have been recently very significant. Kelsey Young and Jacob Leacher have been so important for me getting here today because while I was in grad school, we met in a field deployment for RISE, and they decided they wanted me to come to Goddard to be a postdoc. That kind of motivated me to finish my degree so that I could go work with them at Goddard. So I want to say thank you to them. I'm also going to say thank you to Noah Petro, who is currently my lab chief, and he has been one of the most caring and supportive lab chiefs I could have asked for. The moment he heard of the Viper news, the first thing he did was call me and tell me that I was going to be okay. And then also, thank you to all of you here in the room. You are what makes being a planetary scientist fun, and all of you online. Okay. So I recently, well, not recently, he's 2 years old now, but we recently grew our family to have a little one. And it made me start realizing what my parents went through when they were raising a kid with dyslexia. So if any of you have children that have a learning difference, here are some of my advice as somebody that's been the kid. Support and encourage them. I think that doesn't need to be said. Be there when they fail. Failing was an important part of my journey here because without failing, I wouldn't have learned. I wouldn't have become stronger to get here today. Read to them. We're always told to read to them, and that is great, but have them also read to you. Have a structure around homework, but be willing to change it. What might work now might not work in 6 months or a year. Show them that the hard work does pay off, whether it's in your personal relationships, at work, at home doing chores. Hard work is so important for a child to see when they have a learning disability. Help them, but make sure that they try it first and make sure they try it again. Explore their interests to their fullest ability, because honestly, my passion for lunar science and remote sensing instrumentation is what drives me today, finding a passion. Now, one thing that I forgot to put on this slide was what helps me on a day-to-day basis in communicating my science and talking to everybody here. One thing that my parents thought was, well, she wants to be in plays, she wants to be a model, she wants to be an actress. Let's put her into the John Robert Powers Modeling and Acting School. This helped me immensely because they taught me how to be presentable. They taught me how to speak in front of people, how to be a friendly face to everybody. So I felt like that was a really important part of me being here today too. So I want to say thank you to my husband for always supporting my dreams and also being my rock in the hard times. And to my son, Liam, who is showing me how to see life through a toddler's eyes, which is really fun. And then I just wanted to put up this little statistic here. This is an Adobe test that you can take because they're working on how they can help accommodate people with dyslexia. So you take the test without a reading ruler at first. My score was 118 words per minute. And then you use different rulers to help you read. And one of the rulers is a light box, and it improved my reading rate and comprehension by 20%. So I think that's pretty incredible. And I'm excited for when Adobe actually comes out with this in their Acrobat so that I can actually use it to help me read papers and produce proposals. So I guess my parents ended up being right in that I did join the circus. But I just have to say, thank you so much for having me here today and for letting me accept this incredible honor.